Okay, so now that we have looked at some of the isotopes of the different elements, we're gonna actually talk about how to calculate the average atomic mass. Okay, now this number is on the periodic table, so you can actually check your work and see if you're doing this correctly. However, it is imperative that we understand where this number comes from, because knowing how to get this number shows that we understand how a sample of an element works. So let's talk about how we do this. So to calculate the average atomic mass, step 1, move the decimal of the percent 2 times to the left. Okay? Because we're typically given our percent composition or our percent abundance as a percentage. What percent of any sample is going to be this particular isotope? In order to do the calculation, we do not want it as a percentage, we want it as a decimal. So to get it from percentage to decimal, we move the decimal 2 places to the left. Step 2, multiply the abundance by the mass. Okay, so that percent abundance, we've changed it to a decimal, so now it's just the abundance. We're going to multiply that by the mass of that isotope, which has to be given. So that's a number that we will give you, okay? It is experimentally determined using what's called a mass spectrometer, but since we lack a mass spectrometer in our classroom, we will simply give you that number for the atomic mass of your isotope. Step 3 is to repeat steps 1 and 2 for all isotopes. So we do that for all of the isotopes of the element. All right. Step 4, we take the final numbers and add them together. And the unit for this, AMU, which stands for atomic mass unit. Okay? So those are our 5 steps. We're going to do a couple of examples, and then I'm going to turn you loose to complete the rest of the examples on your own. You are going to want a calculator. A nice simple calculator like this will work. If you don't have a calculator like this at your house, there is one that you can Google. Just Google a scientific calculator and one will come up.
Good morning, Bob.
All right, so let's start with our isotopes of hydrogen. Now we know the percentages because we got the percentages from our FET activity that we did. So we're gonna use those same percentages over here, but I went ahead and I looked up the experimental masses for hydrogen isotopes. Okay, so the isotope mass for H1 is 1.007825 AMU. The percentage we got for that was 99.9885%. H2 has a mass of 2.01410,178 AMU. Excuse me. And the percentage that we got for that one was 0.0115%. Okay. Whew. So step 1 is to move the decimal of the percent 2 times to the left. So for 99.9885, I'm going to move it from here 1, 2, to the front, and that gets rid of the percentage. So this is 0.999885. For this one, now you have to be careful with numbers like this because we already have zeros in front. And so we're gonna put in zero as placeholders for any places that we don't have. So I'm gonna take the decimal from here and go 1, 2. There's not a number there, so I'm gonna put in a 0 as a placeholder. So this is 0.000115, and then we can dump the percentage. Step 2 is to multiply the abundance by the mass. So I'm gonna take this abundance and I'm multiplying it by this mass. So let's do that in our calculator. I have an abundance of 0.999885 times a mass of 1.007825. That gets me a very long and messy number, 1.0077091. I'm gonna repeat steps 1 through 2 for all the isotopes. So I'm gonna do the same thing for H2. We had an abundance of 0.000115. We're gonna multiply that by our mass of 2.01410178. And that gets us a very messy little number, 0.00023162. Step 4 is to take the final numbers and add them together. So I'm gonna take these two numbers that I got here and I'm gonna add them up. So 1.007791 plus 0.00023162. And that's gonna get us 1.008022622. And the unit we put on this is AMU. Now, cool thing here, I can check, make sure I did it right. So if I pull out my periodic table, find hydrogen, what's the value on the periodic table? 1.008. Did I get 1.008? I did. Now look, we have more numbers than that. So here's something that you need to know about your periodic table. Your average atomic mass values that you have on your periodic table are rounded. They always are, okay? And different periodic tables are gonna report these numbers differently depending on how and where they decided to round the number, all right? So you will notice if you are using a periodic table that those numbers might differ a little bit depending on where they rounded the number. So when we're taking a test and when you need an average atomic mass, make sure that you're always using the periodic table I give you, because it will be rounded slightly differently than maybe whatever other periodic table you might find. All right, so I'm gonna go ahead and I'm gonna give you all of the masses for all of the remaining elements on this list that you have here. And I'm gonna let you copy them down and then I'm gonna let you practice. Okay, so go ahead and pause the video right here and go ahead and copy these numbers down. And then I'm gonna do one of these longer examples with you as well so that you have sort of an example of what to do when you have 3 isotopes. Okay, so let's look at neon. I'll do neon, then that way I've done the top and the bottom and you're good to roll. All right, so for neon, we have 3 isotopes and the process is exactly the same. So let's go ahead and grab our percentages. For neon 20, the percentage was 90.48%. Neon 21 was 0.27%. Neon 22 was 9.25%. All right, so step 1 is to move the decimal of the percent 2 times to the left. So I'm gonna do that for all 3. I'm gonna take that 0.9048. Careful with this one. 1, 2, put that 0 in as a placeholder, 0.0027. 1, 2, put that 0 in as a placeholder, that's 0.0925. All right, and that loses us this percentage. Now we have it in decimal form. All right, step step 2 is to multiply the abundance by the mass. So for neon 20, we have 19.992440 times our abundance of 0.9048. That's going to get us 18.0891591. For neon 21, we're going to take our mass, 20.992440. We're going to multiply that by our abundance, which is 0.0027. That gets us 0.056679588. And then for neon 22, we have 21.991385 times our abundance of 0.0925. That gets us 2.034203113. The last 2 steps are to add together and put our unit. So let's add these 3 numbers together, all 3 numbers. We're gonna do 18.091591 plus 0.05667958 plus 2.034203113. And that's going to get us a mass of 20.1824797 AMU. Grabbing our periodic table to check our work, we find neon over here, 20.180. We're pretty close here. There's something funny with the rounding, but it may just be that these percentages here were pretty well rounded, and so they're not as accurate. All right, so you are going to do the rest of these, and then you are going to upload a picture. You must show all your work. The answers are on the periodic table. I don't care about the answer. I need to see that you can show me how we get to that number. So what I want to see is your work for these other 5 problems.